Welcome once again to my tutorial center. Let's quickly look at this question on vector algebra. Okay, look at the question. Says given the vectors a equal to I minus 2j plus k, comma, we have b, vector b equal to 2I minus 3j plus 4k, then find a, the unit vector perpendicular to each of the vectors a and b. The unit vector that is perpendicular to each of the vectors a and b. Okay. Then b, the sine of the angle between a and b. Remember that we told you that in my former video I told you that a vector quantity is a quantity that has what both magnitude and what direction. So if we have two vectors now acting at a point, so there has to be an angle between the two of them. So we are not looking at the diagrammatic representation right now. So let's quickly look at the question. Let's quickly look at this A. The unit vector, let this be the unit vector. The unit vector is given by this. Okay. And this is the unit vector of that is acting perpendicular to other vectors. And it is given by the formula that say A times B, that is vector products all over the magnitude of this vector product. Okay, so this is the formula that is used to calculate this unit vector. So it means that the vector products then divided by the magnitude. Remember I told you that the magnitude of vector is different from the vector itself. Now first of all, we have to look at this product first, then before we find the magnitude. And in vector, this is called the cross product or vector product. So now, for us to get this, we have from the question, we are given that your A is equal to 2, okay, we have I minus 2j then plus k. Okay, we are given that B is equal to, we have a 2I minus 3j plus 4k. So what we are going to do now, vector product says we are going to arrange this in an array times B, that is the vector product of the two vectors is given like this, I, then we have j, we have k. What does that mean? We are going to look at the coefficient of each of these I component and j component and k component. So here for vector A, we have the coefficient of I here is 1. You put it here. Then the coefficient of j there is minus 2. You put minus 2. The coefficient of k there is 1. You put it here. Now let's go to vector B. The coefficient of I there is 2. Here j is negative 3. Then the next one is 4. Okay. So of course this has become a determinant. This is in a matrix form. So we are going to use the determinant method to find the product now, which is what we are about to do right now. So let's go. If finding the determinant, I will have to take this one as my principal row. Mean that if I take I will have I. Remember, if I take it from there, the negative sign, we will have plus, negative, plus. Then minus, positive, and minus. So we are not going to use this since I am taking from this up here. So I have my I, then I'm going to multiply. I will not take any element from here. I will not take from here, which means I'm going to take negative 2, negative 3, negative 2, negative 3, then 1 and 4, 1 and 4. Okay, then I'm going to have a minus j because I am taking this sign. Then I will also cover here. I will not take from here that column of j. Then I will take a 1 and 2, 1, 2. Then here I have 1, 4, 1, 4. Okay. Then the next one is plus k. We have to multiply. So now I will not take element from here. I will not take from here, which means I'm going to have 1 and negative 2, then 2 and negative 3. We have 1, negative. Okay. Alright. We have 1 and 2. Alright, that's not negative. 1 and what? 2. Then negative 2 and negative 3. Negative 2, negative or 3. So that is that. So let's clean the board so that we can make use of the other side. So now we have the principal diagonal here. Subtract this from the principal diagonal. Minus 2 times 4, it will give you or minus 8. Then I is here, minus 8. Then this one times this gives you negative 3. Because of the minus we are going to have become what? Plus 3. Then minus j. Minus j. Here, 1 times 4 is what? 4. Minus 1 times 2 is what? 2. Then plus k. Here we have 1 times minus 3, 2 or minus what? 3. Minus 2 times 2 is what? Minus 4. Plus, because of the negative we are going to have, it's going to become a plus 4. Okay. So now let's go. This one, this gives you what? Minus 5i. Then this one minus this is what? 2. Minus 2j. Yeah, this one becomes what? Positive 1, which now give what? Plus k. So this is not the what? The cross products is equal to what? Minus 5i minus 2j plus k. That's it. So now how do we get the magnitude now? The magnitude, which is a times b, will now give us what? You find the square roots. Square root or the squares of each of them. Mean that well, the coefficient of I here, which is minus 5, then I will square it. Here, I have plus, then minus 2 here, I will also square it. Then plus, here is what? 1 square. Okay. Then, let's finish it here. Minus 5 square, that is what? 25 plus, here is what? 4 plus 1. Magnitude now is equal to square root of what? 30. Alright. But remember that what I said, our unit vector that is perpendicular to the both of them is what? The products, the cross products divided by what? The magnitude. So what is our cross product? What did we get? The cross product is this. Oh, okay, this is the cross product here. This is the cross product. A times B is this. So this is the cross product here. We have minus 5i. Then minus 2j plus k. So mean that what? Our unit vector now is equal to, here becomes minus 5i minus 2j plus k all over square root of what? 30. So if you wish, you can put it in another form. So this is our unit vector. If you find the value of this, no problem. Then if you wish to simplify further, no problem. Now let us go to the B, the sine of the angle between A and what? B. So we have a formula for that. So let's go. Okay, the sine of the angle between A and B is given by sine theta equal to the magnitude of the products, then all over the product of the respective magnitudes. That is what? A. Magnitude of A multiply what? The magnitude of what? B. Okay. So that will now take us to what our A is. We already know this. We calculated this as our root 30. So let's quickly recall our vector. What is our vector A? Okay, let's quickly go back to that. B magnitude. Now let's go. Your A magnitude now is equal to, you take the square root of all the coefficients of each component. Here we have the coefficient here is 1. Come what? 1 square plus coefficient here is 2, negative 2, minus 2 squared. Coefficient here is 1 plus 1 squared. So which will now give us equal to the square root of what? 1 plus 4 plus what? 1. So your magnitude A is equal to the square root of what? 6. Alright, let's look for that of B. Magnitude B. Let's look for magnitude B. So we have the first element there. Coefficient there is what? 2. We have 2 squared. Then the next one is what? Negative 3. Then square it. While the other one is what? 4 squared. Okay. So it means that what? Our magnitude B is now equal to the square root. This is what? 4 plus 9 plus 16. 4 plus 9 plus 16, which will now give us equal to the square root of, this is what? 29. That is what? Square root of 29. 4 plus this is, that is 29. Now let us go to our formula now. This is the formula here. So we've known this and that. So meaning that what? Our sine theta, the sine of the angle between them. You are not asked to find theta, just the sine of the angle, which is now equal to what? What is our magnitude? That is magnitude of what? The product is what? Square root of what? 30. Square root of 30 all over. Then what is the magnitude of A? Is what? Square root of 6. Square root of what? 6. Then multiply by what? Square root of what? 29. 29. Now it now becomes equal to, you take according to sword. So this becomes what? The square root of 30 all over. This times this got square root of what? 174. Okay. So we can just leave the answer in a radical form. So it gives us equal to what? We have what? Simple root 30 over what? 174. So if you like, break it further. So this is how far I can go. So let's stop here. So on your own, you can simplify, can reduce, or whatever. Okay. If you find this class very interesting, please do not hesitate to share this video. And also do well to subscribe to our YouTube channel. Bye.